Alright guys, welcome to the introduction to Conic Sections, instructed by Vancadaby. So, okay, so basically this is one of those videos where it's like, if you want to learn about Conic Sections but you don't want to go through all that jargon all those other videos do, this is the correct spot. Okay, this is the correct spot. Alright, let's get her on. What is a conic section? Okay, so basically a conic section is a curve produced by the intersection between the cone and the flat plane. Or in simple terms, you put like a sheet through a cone, and whatever shape you get with that intersection is what you get. Okay, there's four types. There's circles, ellipses, parabolas, and hyperbolas. So, yeah, there's four main types of conic sections: circles, ellipses, parabolas, and hyperbolas. So basically, circles are those round shapes where technically all the points are the same distance from the center. An ellipse is basically just a circle that's stretched out. And parabolas are just U-shaped curves that can open either up, down, left, or right. And hyperbolas are curves that have two parts, like they're two parabolas facing away from each other. But keep in mind, hyperbolas are not actually two parabolas. Now, this image here shows a bunch of complex stuff you don't need to know. Basically, if you have a double cone, this is a circle. You go perfectly perpendicular to it. An ellipse, you tilt it a little. But in a parabola, it's exactly parallel to the edge. In a hyperbola, think of it as it's so steep, it accidentally enters that second cone, causing those two parabola-like shapes. Now, this upper and lower part, that's just referring to the cones, but also, yeah, you don't really need to worry about that. Okay, so circles, we're going to start with them because they're the most basic. They're actually a special kind of conic section that is formed when a flat plane intersects a cone exactly perpendicular to its axis. All the points on the circle are equidistant, the same distance from a central point. That is, well, it's called the center. So let's hit the formula. I'm sure if you take an algebra, you're familiar with it. It's basically just x squared plus y squared equals r squared. And the minus h minus k, just move it around the Cartesian plane or just the grids. So we also have ellipses, which are basically the generalization of a circle, but also not really. But they're basically ovals formed just when a plane intersects a cone at a specific angle. Now they have two focal points, and the sum of the distances from any point on the ellipse to the two foci is constant. So basically, you say have one here, have one here. You take any point, and you take this line and this line. That'll always sum to the same thing, regardless of on what point on that oval you choose that point to be. So if I go here, this line plus this line is the same as when I go here, and this line and this line, the sum of them. So that's true for all points on this ellipse. That's like a property of ellipses. Now the formula is exactly what you expect. It's just the circle formula, and you divide by the stretching factors. And instead of equaling r squared to equal 1, because a squared and b squared are pretty much the radius. Okay. Now parabolas. They are U-shaped curves formed by a plane intersecting a cone at an angle. More specifically, an angle exactly parallel to the edge of the cone. And they also have a focal point and also a directrix line, with the distance from point to focus equaling the directrix distance. So basically, you take a point, the focal point, and a directrix line, and you draw a line, like the distance between like the focal and this is the same as this from this to the directrix line. Now there are two formulas. Y minus k equals a times the quantity x minus h squared, and the same is for x minus h equals a times the quantity y minus k squared. This pretty much just determines the direction it opens. Like if you use y or x, that would determine the direction the parabola opens. Now the hyperbola is a curve with two parts, similar to two opposite parabolas that are all formed when a plane intersects both parts of a double cone. Remember, it's like the cone is so steep that it accidentally slips into that second cone. Now this formula is similar to the ellipse, except you picture it going so steep it passes the tilting point, and instead of a plus, it's a minus. You picture it so like ellipses and hyperbolas are kind of like opposites, where an ellipse is like, I mean, yeah, they're not real. It's just a minus. Hyperbolas are just a minus. Ellipses are just a plus. Okay. So what are foci? There are 2 points on the major axis of an ellipse that are equidistant from the center of the ellipse. The major axis is just referring to this big line, or the big diameter, and also the minor axis is just the small diameter. Now this is the formula. Now this might seem familiar. C is radical a squared minus b squared. It's like a weird version of the Pythagorean theorem, which instead of plus it's minus. Why? Well, you don't really need to know that. I mean, I could do that. I don't know. So basically, I find the C, and it's just h plus or minus ck, where h and k are just referring to like the center of the ellipse. Like that's what the h and k points are. Okay, so what is a directrix line? A directrix line defines a parabola. So we're basically all the points on the curve, as shown in this picture here, are equidistant from the directrix in focus. So it's a point here, it's an equidistant. There's a point here, it's also an equal distance. Now it's on to the spooky, scary terms, eccentricity. It's basically just how close it is to a circle. There's nothing really special about it. I mean, yeah, there's these kind of complex formulas, but pretty much it's just the smaller the value, the closer it is to a circle. So of course circles, since they are a circle, have 0, and ellipses are between 0 and 1. And the parabola is 1, where it's basically is just barely too stretched out that it doesn't actually end up closing in on itself. And then the hyperbola just elevates that. So like a hyperbola would have larger than 1. There are these formulas, you can kind of remember them, where ellipses is minus, hyperbola is plus. And these special stuff is just to make sure that the square root is positive, so there's no imaginary eccentricities. So what is the difference between a parabola and a hyperbola? So parabolas, as previously stated, have an eccentricity of exactly 1, and hyperbolas have an eccentricity greater than 1. Parabolas have no asymptotes, where a hyperbola has 2 asymptotes. And parabolas are parallel to the edge of the cone, while the hyperbola intersects both of the cones. Remember, hyperbola is so steep, it slips into that second cone. So parabola has 1 focus in directrix, while hyperbola has 2 foci in directrices. Of course, why are both confused? Because they're both open curves and have a focus. Don't get these confused, okay? I'm watching you. Don't get these confused. Okay, so yeah, conic section formula. If you have observed the different formulas, you may think that, there could be a general formula for all of them. And this is it. And it's basically just the quadratic formula on steroids. It's ax squared plus bxy plus cy squared plus dx plus ey plus f is 0. Now I bet you're wondering why it says here a, b, and c can't equal 0. Well, do you know why? Because if a, b, and c equals 0, it's just a linear equation, which is, by the way, not a conic section. So yeah, that's why a, b, and c cannot always be 0. Because if they all were 0, then it's not a conic section. It's just a line. So yeah, because of this spooky formula, like how am I supposed to be able to know what kind of conic section it is? Don't worry, I had that discriminant shortcut. No, you're not gonna see discriminant shortcut in any of your like math textbooks. I'm just gonna call it that, just to help you out. Okay, So, due to having so many variables, it can be difficult to tell what conic section the equation gives you. However, there is an easy shortcut using the discriminant, which is b squared minus 4ac. Now, this also looks familiar if you take an algebra, because that is exactly what's under the square root of the quadratic formula. So, for an ellipse or a circle, if b squared minus 4ac is less than 0, then it is an ellipse or circle. For a parabola, if the discriminant is exactly 0, it is a parabola. And for hyperbolas, if b squared minus 4ac is greater than 0, it is a hyperbola. Also, why it says ellipse or circle is because if a equaled c, so basically the major axis was the minor axis and b is 0, so there's not that weird xy thing because that's not in circles. Yeah, it's a circle now. It's not an ellipse. This is like an if and only if. It's if and only if a equals c and b equals 0 and a discriminant is less than 0, it is a circle. So yeah, I'm quizzing you. If I could get away with this, no, you're getting quizzed. I hope you're paying attention. So, if b is positive, what must it be greater than to make this a hyperbola? I'll give you some time to figure it out. Pause the video. Okay, so if you're stuck, here's a clue. Just use this. Just use this. This thing helps you out. Just use it. Okay. Yeah. Okay. I guess I'll give you some more time. Okay, so if you did it all correctly, b should be greater than 4 square root of 10. Or 4 radical 10. Because if you just solve for b for the hyperbola, then you'll end up getting that b is in fact 4 radical 10. Now the reason it's not greater than or equal to is because if it was or equal to, then it would end up being exactly 0. But that's not a hyperbola, that's a parabola. Okay, so once again, what is the value? What must a equal to make this conic section a parabola? So I'll give you some more time to figure that out. Okay, if you did the math, actually wait, no, before that, remember that this thing doesn't matter. The discriminant shortcut only uses a, b, and c. Remember, it's b squared minus 4ac. So we want b squared minus 4ac to be exactly 0 in order for it to be a parabola. If you do the math, it must be exactly equal to 25 over 32. Okay, so once again, what must c equal to make this a circle? I'll give you some more time to figure that out. Once again, this term doesn't matter. Discriminant shortcut only uses a, b, and c. So remember, for ellipses or circle, b squared minus 4ac must be less than 0. As if I go up here, ellipse or circle, yeah, b squared minus 4ac is less than 0. So that must be true in order for it to be an ellipse or a circle. Okay, got your answer? Because if you got anything, you're wrong, because it can't be anything. Because that b term must be 0, and as a matter of fact, it is not 0. So, sorry if you fell for that. Remember, if I go back up here, a equals c, b equals 0, and the discriminant is less than 0. It is a circle. Now, in fact, if you go down here, as it turns out, you must say that, of course, it'd have to equal 300, but no, because b is not 0. So, unfortunately, nothing works. At least, nothing works in, I guess, this domain, but I don't know, maybe some complex stuff. Maybe I'm just wrong. So, once again, okay. So, if f is negative, what must it be less than to make this an ellipse? Yeah, you got your answer? Well, you shouldn't have, yeah, every answer works. It's not in the shortcut. It's b squared minus 4ac. There's no f in there. It's only I only see A's, B's, and C's, no F's. So, okay, yeah, every answer works. I guess F's in the chat if you didn't get that one. Okay, that was weird. Okay. So, a plane. Oh, yeah, what is the conic section? Okay, so a plane intersects a cone and it is parallel to the edge of the second cone. So, what conic section does this produce? Okay, I'll read that again. So, a plane intersects a cone parallel to the edge of the second cone. Does that sound like any conic section? Because if you said a parabola, you were absolutely correct. Because remember, it's like exactly parallel to the edge, so it's just enough to completely open up, like, and not be bounded. Like a circle and ellipse are bounded and have like an area. A parabola doesn't, but it's not so steep. It's not so steep that it ends up being a hyperbola. Okay, so similarly, a conic section has an eccentricity of 0.45. What is a conic section? Okay, if you said an ellipse, you are correct. Remember, the eccentricity is how close it is to a circle. A circle. Sorry. Okay, so a circle has eccentricity of 0. But an ellipse, when you stretch it out, it gets closer and closer to 1 until you stretch it out so much that it just never, I don't know, it completely breaks. There's no bounded area. It breaks so much that it completely escapes the presentation. So yeah, parabolas are not bounded. And since this is less than 1, it is bounded, but it's not 0, so it's not a circle. Therefore, it's an ellipse. Okay, what is the conic section? Hope we got paper and pencil out because a conic section has this formula. What conic section is it? No, actually, you don't really need paper and pencil for this. It's, for me at least, I mean, it's a good skill to practice mental math, so when I put that paper away, try to solve this in your head. Remember, b squared minus 4ac. Just calculate that and use the discriminant shortcut. Okay, so if we work it out, this is b, so that is 49 times 4ac, so 4 times 12. Yeah, 4 times 12, that is 48. 49 minus 48 is 1. Since it is greater than 0, it's a hyperbola. So great job to those who figured it out. Gold star, hang on. Yeah, star for you. Okay, lastly, what is the conic section? A flat plane intersects a cone perpendicular to its axis. Okay, I'm pretty sure you figured out the pattern. It's a circle. Okay, well, I mean, that's pretty much it. I mean, a part 2's. Okay, why not do a quick review before you click off? Okay, just to remember, so we don't get let's not get sidetracked. Okay, remember we were discussing circle, ellipse, parabola, hyperbola. Those are the 4 main ones. They are formed by the intersection of a flat plane and a cone. There's this thing called eccentricity in formulas, which would be a pretty useful tool to have in your toolkit. And also remembering foci and what a directrix is, because those might appear in your Algebra 2 class. Eccentricity, basically how close it is to a circle. The difference between a parabola and a hyperbola, so you don't embarrass yourself, and conic section formula, which really only the discriminant is useful. And then we did a bunch of quizzes together. So I hope you have a great day. Let me know if you have any suggestions, because there is a part 2. I already have the presentation done, so if you want to see that, then let me know in the comments. Okay, goodbye. I hope you have a great day.